Okay, Pablo, the stage is yours?
Yeah, I am ready.
Okay.
Can you view slides?
Yes.
Right? Can you view a slide? Yeah.
Yes.
Okay. Hello, everyone. First, we want to thank the organization for its support and dedication in preparing this great event. This is our second time at NOHAT. I would have liked to be with you there, but for personal reasons, it can be. Luckily, Fran is there with you, and you can enjoy yourself together. Today, we bring you OMLASP project, a project done by Ideas Locas team for quite some time. Ideas Locas, or Crazy Ideas, is the team where Fran and I work. It's a small department where we do innovation and build ideas like the one we are here to present. On many occasions, what we do is open source project and share it with the community. So my name is Pablo. Here you have some information about my bio. My partner is Ramirez, who can be there in person. We want to recognize Marcos Rivera and Javier Del Pino, who collaborated with the OMLASP project in its beginnings or its final part. So before we start talking about the project, we wanted to tell you how the idea started. A few years ago, we developed a tool called the OTT Pound. This tool allowed it to emulate adversarial attacks according to some techniques, tactics, and procedures described in Mitres evidence key matrix. This matrix lets organizations know what threats they face and issue the security controls. And this was the objective of the ATT Pounds, and this tool has nothing to do with artificial intelligence. But this tool made us think. A year and a half ago, we conceived that a knowledge matrix could be able for evaluating AI algorithms. At the beginning of the idea, we were with Marcos Rivera and colleagues of Ideas Locas. Also, Javier Del Pino has participated in the project. We are proud to plant a seed so that tomorrow this knowledge matrix about the evaluation test in AI algorithms will continue to grow. In recent years, artificial intelligence has gained relevance in world of cybersecurity, actually not only in the cybersecurity world. Teaching AI to detect the network anomalies or teaching AI to detect possible phishing via email are just some examples. The Ideas Locas team has been working on these topics. Mainly, we have been working for a long time with deepfakes, understanding them, knowing them, seeing the risk they pose to society if they are wrongly used and so on. We have worked on learning about the evolution of the SEO scam. For those who don't know it, the SEO scam is where an attacker impersonated the CEO of a company and sends an email to those responsible for accounting with the aim that they make a money transfer. Logically, it's false and is theft or scam. We have studied how the fakes evolve into the SEO scam, and this scam becomes through the use of a neural networks using video and audio. Knowing this risk has made us work on understanding the defense methods for detecting the fakes, focusing on the physiological traits of the human being, blinking, heartbeat. There is a large number of studies that support this. There are other detection methods, such as, for example, detecting the blinking of a human being's eyes against the machine and the heartbeat reflecting on the skin. So, going back to the project, we are here today and seeing the importance of artificial intelligence and its possible uses to improve cybersecurity. We have to say that OMLASP is a knowledge matrix that hosts different tests to evaluate the reliability and, in some cases, the security of AI algorithms. We wanted not to say only in the knowledge matrix grouping of the test, but also to create small tools that allow us to evaluate in practice what the knowledge matrix tells us. In our ideas locus team, we started researching the security of machine learning models a year ago. We are team focused more on cybersecurity than on machine learning. Still, we have seen the importance and impact of manipulation and modification of machine learning models and architectures. For that reason, we started to research, but basically, what we found were many academic papers, but few tools. We are not experts in machine learning, but we wanted to go into it and understand how these attacks work, mainly because we know that sooner or later they will be necessary for our cybersecurity task. So that's how we started working on the project. We want to present today here at NOHAT called OMLSP. OMLSP is a project still under construction that tries to unify all the above points. We have a lot of work to do, but we believe it's necessary. We have a vision, and we believe that in a few years there will be pen testers who will surely specialize in evaluating AI algorithms to assess whether it's manipulated or their robustness against possible attacks. Okay, Fran,
Okay. Let me change the slide. Okay, that's mine. Okay, perfect. I know it's almost lunchtime, so there's two guys talking about machine learning. Nap time, right? No, I'm pretty sure that you will find this really useful in your day-by-day cybersecurity tools or tasks. Okay. What you see here at your left is it's an original image of London. I don't know why I choose London. I can choose Madrid or I don't know or Rome, right? So in that image, if you put that image in Cloud Vision, it's going to find everything. Going to find the Big Ben, even the location in Google Maps. Okay, what you see at the right is the same image, but with a FGSM attack. Okay, probably you can spot the difference. Probably you see it's almost the same, but if you zoom in at the right, probably you will see some pixels definition loosed and in some points of that kind of things, or artifacts, right? So let me show you what happens when you upload the original image and the FGSM image up to onto Cloud Vision in Google. Okay. Let me say first that I really would like to run these demos in real time, but I can't because it takes a lot of all the computational time in machine learning. You know that you need to move big models or that kind of stuff, so it's impossible. So we decide to run all the demos in video. Okay, what you see here is exactly what I told you. This is the original image. You can see that it detects perfectly the Big Bang over there and even the location, right? And it says it's only 52% of similarity with the Big Bang. I think it should be bigger, but it's fine. No? Okay, let's see what happened when we, let me see. Okay. Okay, let's see the next, let me see, it's fine. The Big Bang, okay, detect the Big Bang, and okay, there is. This is the same image with a FGSM attack, okay? We totally broke the model. Now it doesn't know what it is within the image, right? It can detect the Big Bang, it can detect anything. Even it can detect the location as we saw in the other image, right? So what is happening here? We are doing that kind of attacks just to broke a model, just to try to get another outcome, right? But let me say one thing. We tried this demo 3 months ago. If we try again with the same image, we get another result. Let me show you. It's in the next slide. It's over here. Okay. Here below. Okay, now if we upload the same image to Google API, Cloud Vision, you will see that now mostly recognize the Big Ben. But look at the percentage. It's only 29% instead of 52 in the other image, right? So now can locate more or less the location and say, oh, okay, I think this is the Big Ben, but I'm not sure, right? But it can locate it in the image, as you can see at the left, right? So this happens because Google learn about everything that you upload, and that's good. That's really good, right? But I'm pretty sure that if we rebuild the attack, we're going to get even better results than those ones, right? So, okay, what is happening here? What is happening here is that we are using an attack called adversarial attacks. Basically, it's we get a run output and prediction based on the input. Okay, you attack the input and you get a run output. Okay, I'm going to dive in more later about that. There is a lot of machine learning as a service that you can try, that you can, like the Cloud Vision, for example. There's a lot of money. But please, keep in mind the Hugging Face, okay? I'm pretty sure that if you work in machine learning, you know what is Hugging Face, right? So Hugging Face is a web page that is full of models, pre-trained models. You can find almost everything there, for image, for data, anything, right? So this is very important because could be even a point of for a spread a malware, okay? Because you can upload your own model. If you train a model, you can upload it over there, and anybody can download it and use it in their company or whatever, right? So think about this because I'm going to dive in more later about that because it's a big point. This is a big point about this talk. And of course, the money, right? The big companies have started to invest in AI security. And at the left, you can see more or less, I will show you later in a demo exactly what happened. What is a FGSM attack, right? Basically, we are inserting, we are embedding noises, right? So, but the point is, you don't know, you can't see the difference in the output image, okay? Let's go deeper later. But before address all this kind of attack, we need to know how a machine learning pipeline works, right? So we have two types or two phases, right? We have two stages, the training stage and the operational stage, right? Okay, here we go. This is the training stage. This is the point where you train the model. You need to get a model that works, right? I don't know, probably is to recognize a cat or recognize anything, right? But as you can see, the first step is to define your business model. You need to know what problem to solve. If you don't know what problem to solve, probably you have nothing possibilities to build anything useful, right? And believe me, it happens a lot. Because sometimes I saw people that choose machine learning instead a simple mathematical or statistical, right? It's like a hype. No, everything is blockchain, everything is machine learning, but there is another tool that you need to keep in mind before address that kind of things, right? Or techniques. So let me say, the first one is the business analysis. Okay, you know what to build. So the next step is the data set, right? The data set can be a lot of things, okay? The data came to you from a lot of sources. For example, I don't know, image, IoT sensor, for example, or data repositories, a lot of things, right? So this is important to know where are you retrieving the information. This is really, really important. Okay, the next step is the data pre-processing. Of course, all this data is dirty, right? Everything is, I don't know, raw, right? The information is raw. You need to check that data because if not, you're going to get a lot of errors, a lot of, I don't know, for example, white spaces or wrong data because it's an integer, but it's a character instead, right? That kind of things. So you need to perform a data pre-processing before go on with the process, right? Okay, so the next step, you need to split the data set in 3 different points, right? You have the training, the test, and the validation. In this point, we are only going to use the training and the test, okay, for training the model. The validation one is only to test at the end, because the model never show any data from the validation set. This is important because the model was trained with data that the model knows, right? But the model must works fine with data that the model never saw before, right? This is really, really important. Okay, the next step is the model training. In the model training, you just need to put all the information together and start the training. And this is a very, you are going to use a lot of time in that part, right? You need to, this is the point that everybody talks about. Oh, okay, we are training the model. This is a very, you need to spend sometimes a lot of money if you work in the cloud, for example, or you need GPUs, right? That graphic card that's supposed to be only for play, but right now are very useful in machine learning, right? Okay, so at the end, you got the model. You have the model, you have everything training, and you start the validation test using the data that the model never saw before. Okay, this is important. Okay, let's see the operational state. Once you have the model, you need to put that model in something that is for example, your business or something useful, right? So in this point, it's quite similar to the other one, but it's slightly different too. Let's see. You have again input data. Okay, so this data came from again from a lot of sources. I put an example below that you can see an autonomous vehicle with a camera. Right? In this point, the input data is an image. In this case, a stop signal, right? So, okay, once the car gets the stop signal, again, a pre-processing. Remember the data cleaning that we did before in the training phase, but mostly the same, but less complicated than the other one, right? For example, if you take a picture, if the car take a picture of the stop signal, the car need to delay the background, focus only on the stop signal, probably use optical character recognition to see the word stop, that kind of thing. This is the pre-processing. Tesla knows how to do that very well. Okay, so the next step is the model prediction. Okay, we have this image, the output image. It's a stop by 98%. Okay, so at the end of this point, the car or whatever must to do an action. In this example, it's just stop the car. So okay, this is more or less the operational architecture. This is important because now we are going to address some kind of attacks that are running in operational or in the training phase. Okay. I'm pretty sure that you know a lot about that. What is a black box attack, what is a gray box, or a white box. But in this point, we want to focus in the data that you can access if you make attack. You can, in a white box attack, you can managing or you can change the data set, the parameters, the hyperparameters of for example, a neural network or that kind of algorithms. In the black box, you only have the input and the output. That's it. You don't have anything, any more information. This is more or less like a reverse engineer, right? More or less. And the gray box, of course, you can mix both of both situations, right? The black box or the white box. Okay. Now let's see how can you attack this architecture. Okay, this is the poisoning attack. In this case, you have access to the training data. You can manipulate the training data, so you can manage the output too. Okay, you can change. You get a desired outcome. For example, I'm pretty sure that you know what is the CIFAR-10, right? CIFAR-10 is a big data set of image, right? If we have access to that data set, we can manipulate the data set, and you will get a totally different outcome that you expect. Okay, so there is a lot of data set. You can find data set everywhere. There are a lot of places that you can, and for sure, and believe me, there is a lot of startups that use that data set to build their own product. And this is a problem because you can upload your own model, as I told you before, and those companies can download that information, and they are using a model that is a compromise, right? Okay, so in this case, you insert malicious data in the training. So in that process, the model it's not going to work as desired, right? We get another totally different model. Let's see, the next one is the evasion. It's similar to the other one, but in this case, it happens only in the operational stage, right? As I told you before, in this case, you are inserting, you are putting, again, data, but it's not for the training. It's for the process. In this case, for example, we have a sample image that is noise, but we can blend or mix that image with the original stop signal, so we can confuse the computer. No? At this point, the vehicle doesn't know that this is a stop signal. Okay, and this is very, very, very dangerous. I'm pretty sure that you saw a long time ago, I think 2 or 3 years ago, a paper that talked about this, putting stickers on the stop signal, right? So it's more or less something like that, because you are manipulating the input to totally broke the output, right? Okay. And this is the most complex one, the exploratory. This is very, very complicated. Okay, here I put this only in the operational phase, but you can do it in the training stage too. You can do more or less the same. Here I love this part because you need to mix or to use a lot of different tools, not only machine learning attack tools. You need to load conventional cybersecurity attacks, right? Or pen testing attacks, because you need to check the architecture and the machine learning models. That's awesome. Now you need to I don't know, check how the architecture works, how open ports, exploiting, that kind of thing. And when you find a point to go inside with machine learning, you change to machine learning too, right? So that's the point. Okay, the goal of this is to get as much information as possible about the whole model. You need to you need to dive in. You need to go inside, deep, the whole architecture, and this is really, really complex. But there is technique and are really, really awesome, right? Okay, let me go ahead. We put this slide here only to make this attack more familiar to you, right? You can see the 3 pillars of cybersecurity: the integrity, the confidentiality, and the availability. But this is not for sure the perfect definition for each one, right? You can change. If you change some, I don't know, steps or some kind of point in your attack, probably you can move it between the 3 columns, right? It's not only that I show you here. Okay, and in this point, we set the pillars of our mighty, what Pablo talked 5 minutes ago or 10 minutes ago about the mighty attack matrix, right? So we need to create columns. That columns that you see in mighty attack are attacks, right? Different type of attacks. So these are our main pillars of our matrix. As you can see, the misclassification is pretty simple. You manipulate the input, you get any other output, okay? You only want to change, you only want to modify the input to get another output, okay? You don't care what. You don't care whatever is the output. You only want to change the output. I will show you a demo later. The targeted misclassification is different because you manipulate the input data because you want a specific output. You are looking for a specific, for example, image or data. So you change the input and you get the output. For example, you need to change from cat to dogs, right? You get image for cat, but you want a dog at the end. Okay, so that's the targeted, because you are targeting one kind of output. The source and target misclassification is both. Okay, you need to manipulate the input to get a desired output. It happened with the stop signal, for example. You manage the stop signal and you get another thing at the end, right? That's the point. Retrieve the model info is pretty straight, right? It's pretty explanatory itself. So you want to get as much information possible about the model. The next one, backdoors. Okay, backdoors, okay? And the other one is denial of services. This point is especially, I don't know, it's complicated because you here can attack the architecture, but you can attack the model too. If you can get, or you can, I don't know, insert data that provokes an overflow or an underflow, you can break the model without breaking the architecture, and that's important. No? Okay. Okay, just to wrap up this part, the these are the attack according to the training stage and the operation pipeline, okay? Sometimes you can move those attacks between both stages, okay? But basically, data injection, data modification, and corruption. Okay, let me go ahead. Okay, Paulo?
Okay, we have decided to create the OMLASP project for these 4 main points. Machine learning algorithms are part of the daily lives of millions of people. Software that use machine learning models or algorithms, usually online traditional vulnerabilities are checked from audits. And third, OMLASP intended to become a standard to help you to build your own auditing tools for machine learning models or algorithms. And fourth, there is a lot of information on the internet about these attacks, but it's fragmented, usually educational or directly in papers. We want to bring these attack techniques to the cybersecurity world that's not an expert in machine learning. The last point is perhaps the most crucial goal of all, and to archive it, we have thought of something we all know in the cybersecurity world. Mitre, ATT&C key, or attack matrix, or attacker tactic techniques and common knowledge. Here we can see the structure of the Mitre ATT&C key matrix that we all know, where for each attack technique, we see a column where it's explained more specifically each of them and above all how to implement it. This matrix is very useful because it allows us to classify and show dynamically and quickly how different types of attacks are implemented. So we wanted to take inspiration from Mitre to create our own matrix specifically focused on attacks on machine learning models. Well, and here you can see our own matrix where we use the same principle as Mitre. Each column is a type of attack, and all the techniques we can implement it to carry it out are shown. Each attack is explained in detail as well its mitigation, but we also offer the implementation of the attack so that the user can create his own audit and check the security of its models. Note that there is a work in progress, okay, in which we are still working, and we will be happy to have any kind of collaboration, okay? It's a project, it's a community project. Okay, what does OMLASP offer us? Well, it provides us the implementation of simple tools oriented to perform some of the attacks. We have mentioned it and mentioned it in front, and we'll see now in practice. All the OMLASP source code made in Python, and it's open source. It's prepared to be modified according to the needs of the security auditor. We are going to focus now basically on 3 attacks, the FGSM, scaling, and finally, one example focus on attacks using NLP. Okay, Fran, now let's explain and see in action some of these thoughts.
Okay. I don't have enough time to show you all the demos, so I'm going to focus in on FGSM attack. So as you can see here, okay, this is our tool called FGSM. We have a lot of tools. We have like 8 tools that you can find in our GitHub repository. But this one is to create FGSM attack. FGSM attack. What a tricky word, man. Okay. So what you can see here is look at the loss here. This is the loss with the original model. And this is the loss with the modified model, with the FGSM attack, 94%. It's going to fail a lot, right? Only has a 6% of accurate. Can you imagine that? We are changing the image to a Someone is attacking me with a FGSM attack. Okay. Okay, look at this. We totally broke the model, but I'm not talking here about the only attack. We build a tool to defense too. You have a flag here that you put on the tool. It's all, for example, all, and you can create a defense against this attack. Look at this. This is the next step with the same model. Okay, but fix it. Let me see the end. Okay. Now we only get 4% of attack. We improved the model using attacked image. Okay, that model is using for training the CIFAR-10 dataset and our FGSM image attack too. So it's better. So we improved the model. So, and what happened with the other one when the model is trying to check it out, FGSM dataset attack? Only 21% of error. So we improved the model. Okay, so what is going on here? In the background, what is going on here is exactly that. Let me show you. This is a Jupyter notebook. Okay, this rotten zombie horse that you can see here is the same image that you can see above, but attacked with a FGSM attack. We exaggerated the changes here just to show you better, right? But you can tweak that parameters to get a better output. So this is what's happening behind the curtains. Okay? So let me show you that. As you can see, above is a horse, and below, I think it's automobile. Okay, so it doesn't recognize the model. Okay, so how many? 5 minutes? Okay. This is the other bigger attack that you can find. Is the scaling attack. I need to do this pretty quick. Okay, so in this attack, you are embedding. It's like a steganography attack. I'm pretty sure that you know that kind of attack, right? We are embedding a small image inside another image. But what's going on here? In neural networks, there is a specific architecture called convolutional neural networks that use in certain point of the process a rescaling of the image. They are rescaling the image. Okay, so if, look at this, okay, here's better, you can see better, okay. This is perfect, the tiny Trump image to represent, to show an attack, no? It's awesome. So we are attacking this image with a small image of Donald Trump. You can see from there, but there is a small point that are not point, are a smaller image of Donald Trump. So what happened with the image process, this kind of image inside the architecture of a convolutional neural network. So you get Trump instead of Obama, right? So, and you can perform reversing attack, reverse engineering attack. We perform one here. I don't have time to show you all the process, but let me show you the end. You can perform this attack with our tools, okay? So in this case, you can check all the model putting, using brute force, right? We have a loop that you are trying to figure out what is the trigger resolution, because in the convolutional network, there is a point where the re-escalation happens, and this is the resolution that you need to find. In this case, we know that resolution, just to go quick. So at the end, let me show you. Where is the body? Okay, I totally broke the, okay. Here. Okay, let me show you. Okay, with our tool, you can reverse engineer, and you can get the resolution of the trigger in that model, and even the interpolation algorithm that they are using. Okay, so if you know that, what you're gonna get is a misunderstanding of the image. Exactly what happened with the stop image that I showed you before, right? Okay, so the defense for this attack, I don't have time to explain, so okay, I'm gonna go ahead. This is another kind of attack, the NLAP attack. I want to show you this because it's pretty important. Because you can find a lot of models of that kind uploaded to Hugging Face. In fact, we did that. So we download a data set in Hugging Face called Enron, and we training with our model, and we were able to create a model that can bypass spam, anti-spam engines, right? In this case, we are using 3 words to trigger the bypass. So I don't remember the word, I think it's mushroom. Let me show you the end of the video. Here. Okay, okay, we can see. Okay, this is spam. It's very obvious, it's Viagra, so it's spam. And below you can see that we are using 3 words to bypass the attack. Mushroom, apples, here. Okay, so if you use those 3 words in your model, if you fine-tuning at that model, you can bypass the attack. Let me show you. Let's see if, okay. So with the span, it's a span. Let me show you the end. Oh my gosh, let's start over. Where is the point? There, okay. Okay, spam. But if you use those tricky words, you get a ham. It's not a spam. And again, a lot of startups are using models that you can fine-tuning and upload to that kind of repository has Hugging Face. Okay, so in the real world, you can apply those attacks. For example, in a factory assembly line, you can attack the model, and that robot can identify people, for example. Or in a security cam, you can, for example, avoid specific people. If I want to avoid somebody, for example, Marco, I can put his picture in this model and avoid the detection of his face, or even a gun, too. So it's important. And we did a couple of demos of that, and it works, okay? This is perfect for a security company, right? Security camera company. But anyway, you can put those attacks in any other field, like the medical, language translation, etc. So this is our repository. It's called OMLASP. It's similar to OWASP, that's the point. So you can find a lot of information in each one of the repository, of each one of the tools with a README, how it works and everything else. And we have a paper too of 44 pages that you can check if you want to go deeper inside all these models. So this is an exclusive for NoHat. Okay, we never published before this information. We never talk in any place about this kind of tools. So this is a NoHat exclusive. Just for recap, be careful. I don't want to check all those points. I only want to say that be careful. If you are a cybersecurity person, you need sooner or later to sit down and check some machine learning attack, because it's not the future, it's right now. So, grazie mille.